Bismillahirrahmanirrahim. Assalamu alaikum and good morning, students. Today I'm going to start with the prime factors. In fact, what are the prime factors? I have already told you. But for the sake of this new exercise, I have to recap what are the prime factors. Now, prime factors are the factors of a number which are itself are the prime numbers. Very simple and very easy definition we have. And for example, what are the prime factors? If I have 30, let me write prime factors first. What are the prime factors? These are the factors of a number which are itself prime numbers. Now, for example, I take 36. For example, 36, and I draw a tree of 36, and that becomes 218, 9, and you see that now the 9 is not divisible by 2. So what I do is go to the next prime number. But my dear students, you have to keep in mind that you start from the lowest prime number. The lowest prime number. You see here, it would have been divided by 3 as well, because it is divisible by 3, but we started with 2 because it is divisible by 2 as well. So I started with 2, and then when it is beyond 2, so I divided by 3. So what are the factors of all these? Are the prime numbers. Now all these are the prime numbers. You see, all these are the prime numbers. So what are the factors of 36? F36 is equal to 2.2.3.3. Now this dot stands for multiplication sign as well. You can write it like this as well. It is up to you, and if your coordinator, if your teacher allows it to do it. 2 multiplied 2 multiplied 3 multiplied 3. So there is another way of doing the same question, but I take another example for that, and that is 48, and that is a division method. Now what we do, you see that this again is divisible by 3, but we start it with 2. 2 times 4 and 4 times 8, 2 1 times and 2, 2 times, 2 6 times, 2 3 times, and when you reach to the prime number, you just stop it. So what are the factors of 48? 2.2.2.2.3. 8 to the 16. 16 times 3 is 48. Okay. Now this has been done. I think you must have understood what are the prime factors. Prime factors are the factors. If you break a number into the prime factors, these are called prime factors. It can be done either by the tree method or by the division method. So I am going to skip exercise 1.8 today, because exercise 1.8 is just a practicing exercise. We'll practice this exercise in 1.9. So we start from exercise 1.9. Exercise 1.9. Question number 1 part. Question number 1, and we'll be doing some parts from each question. So we start from question number 1, part A. 48, and what we have to find is find the HCF of these numbers by means of prime factor. Now we have to find HCF by means of prime factors. So part number A is 48 and 108. 48 and 108. Now there are again, what I told you was two methods of doing. I have already done 48 in my previous example. That was with division method. Now I am going to do it with prime number. I am going to do it with tree method. So what comes here is 2, 24, again 2, 12, again 2, 6, and again 2, 3. Now you see, I am going to check it backwards. 3 2 times 6, 6 2 times 12, and 12 2 times 24, and 24 2 times 48. Okay, it is good enough. Now what I do with this 108 is I write it over here and draw a line vertical and draw a line horizontal. Now you see, this is again divisible by 3, but we are going to start it with 2. 2 5 times 10, and 2 4 times. Again it is divisible by 3, but we do it by 2 because it is also divisible by 2. So 2 2 times, 2 7 times. Now this is not divisible by 2 anymore. So we started from 3. 3 9 times 27, and 3 3 times 9. So what are the factors? What are the outcomes now? 48, F48 is 2 2 2 2, 4 2s and 1 3, 4 2s and 1 3. I simply put a dot in between each of the digit. And F108, there are 2 2s and 3 3s. 2 2s and 3 3s. Now what we have to find is HCF. What we do, we find those numbers which are common as many numbers. Now this one is common, this is common, and this is common. So what is the HCF? Finally, HCF is equal to 2 multiplied 2 multiplied 3. 2.2.3. That becomes 12. Had you ever think that what does it do with these numbers? Now let me do it for you. You see, 48. Divide 12 with 48. It completes it with 4 times. And also divide 108 by 12. It completes it with 9. So you see, both numbers are divisible by one simple number, which is the highest in between the two. Now this is, it could have been divided by 2, or it could have been divided by 3 as well. But the highest factor was 12, which divides the both number solely. So next example, next question. Now dear students, let us try That's number one, part C. The parts I am skipping, you have to do it by yourself. If you find any difficulty in solving those problems, you can ask in the comment box. I will solve it for you. But these are so simple, so simple, so simple that these are very easy and you can do it by yourself. 72 and 90. 72 and 90. We have to find HCF of both. So we start right from here to 36 and to 18 to 9 and 3. So what I told you to check it. 3 times 3 is 9, 9 times 2 is 18, and 18 times 2 is 36, 36 times 2 is 72. Okay. Now for this, 2 times 45. Just see now this stop here. Now you see that this 45 is not divisible by 2 anymore. So we start from the next possible prime number, and that is 3. 3 1 times and 3 5 times 15. It is again divisible by 3. You can check it again. 5 3 times 15, 15 3 times 45, and 45 2 times 90. So what are the factors of 72? Factors of 72 are 2.2.2.3 and 3 one more 3. Okay. And for 90, these are 2 3 3 5. 2 3 3 and 5. So come up with the common factors now. This is common and these two are common again. But this is not common, this is not common, and this is not common. So what is the HCF now? 2 dot HCF is equal to 2.3.3. Once 2 and twice 3. So it becomes 918. So this is the HCF of 72 and 90. Now my dear students, let us find LCM. You remember what was LCM? Lowest common multiple. I have broken up these into prime numbers. Both the numbers are broken up into the prime numbers. I have also found the HCF, and if I have to find the LCM of same two numbers, what I do? Now you see what is the smallest trick in between HCF and LCM. Now LCM I have already taken is 18, sorry. Now you see this was common, this was common, this was common, and the leftovers are 2, 2 and 5. What are the leftovers? LCM is equal to HCF multiplied by, let me write it in a bigger space. Now LCM is equal to HCF multiplied by the leftover numbers. Leftover numbers are 2, 2 and 5. 2.2.5. So what is the outcome over here? LCF was 18 multiplied by 20. That will become 360. So you see that how we find LCM. But in the next question, we'll follow the proper procedure for doing the LCM. The next question. I take next question, part E now. Part E is 100 and 125. 100, let me do it somewhere here. 100 and 125. That it must remain visible with you. I just started right from here. 250, 225. Now this is not divisible by 2, not divisible by 3. Now the next number is 5. 5 times 5. Go and check it. 5 times 25, 25 times 50, and 50 times 2 is 100. Okay, it is done. Check it for 3 because it is not divisible by 2. It is not divisible by 3 either because the number we get by adding the digits is 8 and 8 is not divisible by 3. So what we do, we start it from 2. We start it from the next possible and that is 5. 5 2s are 10 and 5 5. Now the rest is the same. 5 times 25 and 25 5 times is 125. This was very simple. So HCF becomes, what are the common? These two 5s. Okay. Now the commons are, now this is not common, this is not common. Only this pair is common and this pair is common. So we write here 5 times 5. So what becomes 25 is the HCF of the both. Question number 2, and I have to find the LCM. Now dear students, start from question number 2 and we will do, and we have to find LCM now. Remember LCM? Lowest common multiple. Start from part B. And part B says 54 and 72. Once I am going to do the procedure, then I'll just do it right from here. No. The procedure is that for answer, you have to write 54 and then draw a tree. That is 227. Now this is not divisible by 2 anymore. 3 9s are 27 and 3 3s are. Right here, F54 is equal to 2 3 3 3. There are 3 3s and 1 2. And for 72, 236, 218, 2 9 and 3 3. But dear students, you can also do it this way. This is up to you because both are allowed. 2 times and 1 goes out from here and it becomes 7. And now 3 9 times and 3 3 times. Again we got 3 3 3 2, 3 3 3 2, and for this 236 and 218, 9 and 3 3, 3 3 2 2 2, 3 3 2 2 2, 3 3 2 2 2, F72 is equal to 2 2 2, 2 times 2 times 2 times 3 times 3. So what are we going to do now? I told you in my previous question, what are you going to do is, we'll find the factors which are common. Now this is common, this is common, okay, and these are also common, okay. Now write for LCM of 54 and 72 is equal to, now write the factors which are common, write them once, 2.3.3. Now you see I have written once 2, once 3 here, and once 3 here. Now the leftover are, you write all the leftover numbers now. Now this was leftover and this was leftover. I just mark it with another marker. Now this is leftover, this is leftover, and this is leftover. These are all leftovers. So what is the LCM? Now LCM is, we just multiply all of them. Now 3 times 3 is 9, and 9 3 times is 27, and then we have 8. 8 times 27 we have to find. 8 times 27. Now this is 216. 2 3 times 6, 18. 18 2 times 36, 30, 72, 72 3 times. Now this comes. So this is very simple again. To finding LCM of two numbers, you can even find the LCM of 3, 4, 5, and as many as number you are given with. So this is the method. You tell me what part I solve it for you. What? Part F? Okay. Now let me solve part F for you, and that is 95 and 150. 95 and 150. So the procedure, you follow the procedure what I did in the preceding part, but I am going to do it just for the sake of convenience. Now check it whether or not it is divisible by 3. No, it is not divisible by 3 because it comes as 14. So direct we jump over to the next possible, that is 5. 5 1 times 5, and 4 comes out of it, and 5 9s are 43. So you see that this is prime number. So we are finished right here. You can I cannot proceed from beyond this now because we got a prime number here. Now this, you see that this is divisible by 2. Now 275. Now this is not divisible by 2 anymore, but it is divisible by 3. 325. No more 3 now. 5 5. 5 5 25, 25 3 75, 75 2 150. So what will be the axiom? So F95 gives us 5.19 and F150 gives us 2, 3 and a double 5. So there is only one common factor in between the two, and that is 5. So write it whatsoever is common. LCM of 95 and 150 is equal to 5. Now I've written the common factor and then the leftover factors. The leftover factors are, we start from here 19, okay, then from here we have written all the leftover factors. What are the leftover factors? This is the leftover factor, 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 and this is the leftover factor. So we have written all the four here. The common here. This was the common and leftovers. So we have to multiply all these. Multiplied by 5 gives us 95, and then multiplied by 2, then multiplied by 3, then multiplied by 5, we get 2850. The answer is 2850. Now this is a very big LCM for these two numbers. The working was short, but you see the LCM is quite a big one. Now dear students, I think it is enough for today. There are 3 questions still left. So it's time to sign off now. Allah Hafiz and have a nice day.